Good morning and welcome to this Mastering the Machine webinar for the 10th of June 2023. The subject today was Beckhoff and a class that I'm giving next week, which is June the 12th through the 16th for advanced students at Automation NTH, and I went over some of the programming that I've done in preparation for that. I hope you enjoy it. Good morning, folks, and welcome to yet another Zoom webinar, Mastering the Machine from the Automation Academy. It is the 10th of June, 2023, and today's subject is going to be Beckhoff and TwinCAT3. And I did this probably a year ago, a little over a year ago, and at that time I hadn't done any classes or really developed a ton of material, so it was kind of more of an overview. This time I'm going to be going into a little bit of detail about the course that I am teaching next week at Automation NTH. This screen, it's kind of interesting. This is a suggestion from PowerPoint on how to change the screen. And since this is new, I kind of wondered if this had something to do with ChatGPT, because it really seemed to offer me a lot more options than I normally get in PowerPoint. So that's kind of interesting. So a little bit about the Automation Academy. What is the Automation Academy? It is a membership group, and it has a bunch of videos and downloadable documents, a library, things like that. We do have a community with some interest groups. There's not a lot of people involved in that, but it's there for people to use. IO Central. You can find that at www.community.automationllc.com. And of course, you can find the Automation Academy itself at automationllc.com/academy. And if you aren't a member, you would have to sign up and become a member. I named this after a document I put out back in about 2013 called Mastering the Machine. And that can be downloaded here at automationllc.com or on my blog at Automation Primer. So that's a little bit of a description of the Automation Academy, and I don't have a lot of material on this slide, right? So I'm going to substitute the actual PowerPoint that I use in my class. And we're going to talk a little bit about that. And we'll turn this into kind of reading view here. NTH University is an internal program at Automation NTH where interns and apprentices come in and do about a 4-month program building panels and things like that, designing their own software, doing training on the little conveyor systems here. Some of the people here are interns or were interns years ago and have since graduated and been hired by Automation NTH. And then this gentleman here never went through the internship. He is a senior engineer there. So there we go. That's a little bit of a look at Automation NTH and NTH University. Couple, again, splash screens. This is the two offices of NTH, Automation NTH in San Diego, Poway, and here in the Nashville area. So there's a little bit of an overview of NTH University. And fortunately, I've been working for them a couple weeks a month and generating material. And that's where a lot of this kind of stuff comes from. So that's a little bit of a look at NTH University itself. So the course, when I started this, I didn't know a ton of material about Beckhoff. They kind of paid me to learn it, which is great. And now I'm about a year and a half, maybe almost 2 years into that, and have created some pretty good material, kind of based on a lot of the Alan Bradley classes that I do. But I have had to learn some other things that aren't part of the Alan Bradley platform. So I'm going to be going over some of those here today. But this is kind of an overview, and we do lockout, tag out, things like that in case people from outside have to work with electrical equipment, and we give them a handout and they have to take a little test for that. So the products and hardware for Beckhoff, there's a pretty wide range of products. There are the small little PC type PLCs here. Everything in Beckhoff is based on having it like a personal computer, right? It runs on Windows 10 or Windows CE. Those two platforms pretty much exclusively. Some of the older stuff ran on Windows 7 and older Windows platforms, but Windows CE platforms have been around for quite a while. So they're basically industrial PCs running a runtime software and the development software right there on the PC. And of course, you can also run the development software on your laptop. And under the right conditions, you can also run simulations on your laptop. And I'll get into that in a little bit. These are the embedded PCs. These are the Windows CEs. And then these are the Windows 10 up here. And of course, you can see in some cases, they're like HMIs, and they have the runtime built into that, but they're still Windows computers, essentially. So that's a little bit of a look at some of the products that they have, and there's a lot of things that don't have to do with PLCs themselves. They have this XTS linear transport system, pretty cool. They sell servo drives and servo motors. I don't believe they make the servo motors themselves. They brand those from somebody else. They make a lot of these remote modules, and a lot of people will use things like Allen Bradley to operate these remote modules from Beckhoff, because they have Ethernet IP modules, they have Profinet modules. Of course, they use EtherCAT in general. So typically you would get EtherCAT modules if you were running this with a Beckhoff controller, but you can get modules on lots and lots of other platforms. And they have these bus type systems where you can put little IO slices. And that's kind of what I've got over here. You can't really see my controller, but I'll show that in a few minutes here. Something very important, and this is where I did most of my learning. I did go through the Beckhoff courses, and I think the address for that is in here. That's not at this website, right? This is infosys.beckhoff.com, and this is a really, really deep knowledge base. This has just tons and tons of subdirectories and everything from hardware to TwinCAT itself. And as you get used to it, you'll learn where the resources are, where some of the target articles and things like that. So if you want to learn, for instance, function block, and I don't have that up here right now, but if you wanted to learn, function block or structured text or SFC or something like that, you dig deep enough, you'll go many layers deep in some of these categories, and you'll get information on the software itself or the hardware or whatever on this Beckhoff information system. So that's very important. Something that I kind of want to talk about here, I put out originally a blue book that was an overall view of advanced PLC hardware and programming, and it had Allen Bradley and Siemens in it, but I didn't have an easy way to put Beckhoff into that book or reference Beckhoff. So that it was meant to be a kind of a generic thing, but it concentrated heavily on Allen Bradley and Siemens. So I republished that book, and don't know if you can see my screen here, but this is a copy of the book, and I kind of branded it with NTH University's logo on the front of it and minimized it and did not put all the Allen Bradley and Siemens material. I left it very generic. And the reason for doing this, and I'll kind of show this here, is I did make a manual, a course manual, that is a companion book. So rather than having the advanced PLC hardware and programming book, I'm making this basic book, which is about the first third of the advanced PLC hardware and programming book. But then I have these companion modules. So as I create things for other platforms, I've already got an Allen Bradley version. You can see here, this goes into more detail, for instance, than this slideshow does. So, I talk about the field bus components and a lot of the hardware. I list a lot of the parts. And again, I got a lot of this from the Beckhoff information system. So this is available at the Automation Academy.
if you go into the library, you can download this. I'm not sure which version it is. I did kind of redo this. You can see here January of 2023, and I'll probably make at least one more revision on it. Like I said, I'm teaching an advanced class next week for NTH University. So since they're advanced guys, they're going to probably challenge me, and I'm going to have all kinds of new fun examples to put in this book. But this book is the kind of the training manual for the course, and it parallels the this spreadsheet, right? So I talk about a little bit about that book, History of PLCs, What is a PLC? Those who are familiar with my book are already familiar with some of these things. These are the generic things. Right, and then I have this companion module on Beckhoff, and then I go into the trainers specifically. So, for instance, these trainers won't be in the book, right, because nobody else has these trainers. These two trainers are mine. One of them is here. Let's see if I can kind of show it, but it's on the table next to me, and I'll kind of show why I'm having to use that. Let's see if I can drag it over here. Not sure you can see it there, but anyway, this is the trainer. This is the C6015 trainer, which is very basic. You can see up here in the corner, and I think there's some other pictures in here. This is the entire brain of the PLC itself. This is the little industrial computer, right? And then this is the I/O built into that trainer. And then these are just little push button boxes you can plug in. There's some kind of tricks to that. This unit I leave at Automation NTH, and it was on an older software platform. So you had to use something called Remote Manager to program it. But recently, one of the students there did upgrade the firmware to the current version, which is 4024. And then this third unit is the conveyors that I showed you at the beginning. You can kind of see them in the background here. Those conveyors can be run with this trainer. And of course, you can also do simulations, things like that. So one common thing for all these, they all have e-stops, they all have, cycle start and stop buttons, that sort of thing. Mine have little imitation light stacks on them, and theirs have, this is a typical industrial control panel, costs quite a bit more to build than the ones that I've got here. So that's the trainers we use for the class. To do things like scanning, I/O, and things like that. The controllers themselves, this is the 9020, and this is the little tiny module I was telling you about. So that whole thing there, it's just got a couple Ethernet ports and USB ports, things like that, but it's not a lot bigger than a deck of cards. It's pretty small, gets kind of hot, right, because it's running a full computer in a small box. And then it is using EtherCAT to go to this module. But as I mentioned before, these modules could be Ethernet IP, and you could use them with Allen Bradley or whatever. There's a look, again, this one's an HMI-based controller, and people can create their push buttons and things on that. Whereas these other controllers, you have to have a computer or something. And when I show you the software, I'll show you how the HMI works in the computer. There's something called visualizations, and you create a visualization, and it is a screen. So that's a little bit of a look at that. The CP6606, which is the HMI, has a little remote bus module, EK1100, built into it. I'm going to show you a little difference between these EK1100s. With the supply shortage, this was the only one available, and the difference is it has an M8 Ethernet connector on it instead of a standard Ethernet cable like this. So you had to buy special cables for it. It's kind of a pain, but that's the only thing that was available at the time, whereas these use regular Ethernet cables, and they would be more cost effective if you were to get a hold of these. And at one time, I think these were 10,000 of them were on back order. I do go over the hardware and wiring, and I actually have little modules that are kind of broken apart. The sides of them are off, and you can look at the guts of it and see how it works, and you can see the little spring clips from the side. That's kind of a nice thing. And I give people a screwdriver and let them stick it in there to get a sample of what it would be like to wire it. TwinCAT software, which is the core of what I'm going to be covering today, runs in Microsoft Visual Studio. If you install it from scratch, what you'll get is you'll get a light version of Visual Studio. If you already have Visual Studio running on your laptop, it will install on top of it, and you will have both the shell, or you can just run it with regular Visual Studio. One warning with that, one of the guys at Automation NTH did install it, and he had a whole lot of applications on his computer, and it hijacked the applications and kind of thought they were all Beckhoff applications, right? So it put little Beckhoff icons on them and everything. So he didn't like that, and so he uninstalled Beckhoff. I think there's ways to run it, for instance, as a visual machine or a virtual machine. If you run it as a virtual machine, it would be a separate thing inside of your operating system, so it wouldn't interfere with your existing installations. These abbreviations are important. The runtime, XAR, is something that you can install on any PC, but of course they strongly recommend that you put it on a Beckhoff PC because it is optimized for running Beckhoff's hardware and software. They don't take any responsibility for installing it on a just a regular, Windows PC. However, I do run the runtime on laptops. You have to be very careful not to have anything associated with Hyper-V running on the laptop. It thinks that you're trying to cheat the I/O and run everything in Hyper-V. Now you can, oddly enough, create an application within Hyper-V, and then it doesn't know that Hyper-V is running. But if you try to start it up on a computer that, for instance, has Hyper-V associated with laptop security, it will interfere with it and will not let you simulate. It'll let you run the software, but it won't let you run the simulation, which I think if you're going to test code, of course you want to do that. The license itself is based on the capability in the platform, but you do get a 7-day trial license. So even if you want to run a really complex application on your laptop, it will run for 7 days and have no major problems. Go through installation, licensing, the remote manager. This is for other versions. So those of you who are familiar with Allen Bradley, it's kind of like you have a whole bunch of different applications installed on your computer, and version 24 and version 30 and version 31. That's kind of what this is. So if you have an older firmware on your Beckhoff PC, then you would need to use Remote Manager to run that older firmware. That's a little bit unlike, Allen Bradley or Siemens. You can just have the version of the software installed and have 10 versions installed if you want to with all different firmwares. Here, you have to open Visual Studio, select that Remote Manager first, and then open the project. If you open the project first, and I'll show you a little bit of that. Here's the application. That's this little thing right up here where it says Build 4024. If you were running Remote Manager, you would need to select this first, right, before you even open this application. And then you would open the application in that version, and it would operate with that firmware. So that's a little bit about why you use Remote Manager. And I'm glad I got to do that kind of ahead of time, because otherwise I wouldn't have known about it. Go through lots of other things, create new project. I'm not going to do that here. I already have a big project and there's only an hour, so we're not going to create a new project, but it's pretty easy. You go to File and New Project, etc. Connect to the controller and scan the I/O. I might do that today if I have enough time. I did not scan I/O on this existing project. Everything that I ran here was on the simulation on a different laptop, and then because I have Hyper-V on this computer, I had to install this and run it on a real Beckhoff PC rather than running the simulation, the runtime, right? So the runtime in this case is in the little enclosure that I showed you. Okay, so this is what we do in the class. That's the general idea: scan the I/O, get all that set up so that you can start controlling things. And then we go through all these different things. And I'm going to point these out in the software, but there's really not enough time to describe what all these are. So I'm going to briefly describe what these are. This global variable lists are basically like your tag database in Allen Bradley or Siemens, right? They are just lists of tags. As you create them, you can put them in GBLs, or you can make them local to the block itself, like a routine, right? In Siemens, for instance, you create a routine. You can make variables just within that routine right up at the top of it. The same thing is true in Beckhoff. With Allen Bradley, you have a program, and then the program has tags associated with it, and that's about as local as you get, although you can pass local variables and things, but people usually don't do that. Other terms that you see here, so the GBLs are the variable lists. They're just lists of tags. The IO links are what devices you would connect to, right? So all those little widgets that I showed you there with the plug-in modules, that's where you would list all those out. DUTs, that's just a same acronym as a UDT in AB and Siemens, right? They call them UDTs there, or UDDTs. Here they're data user types rather than user data types. Okay, and then POUs, it's another term that's used widely in code assists, are blocks like function blocks, like functions, like routines. And so as you build your routines, you can define something as this is going to be a function block, making it reusable, or this is going to be just a program, which is the same thing as a routine. And there are some differences there as far as how you pass variables back and forth. So there's a list of the POUs, programs, right? Basically routines, functions, and function blocks. Function blocks have permanent memory associated with them. You can pass variables in and out, whereas functions don't. So functions are usually done for things like math conversions, things like that. One big difference here, and if you follow people like Jacob Sagatowski, he's very popular on LinkedIn and YouTube, and he covers a lot of this stuff, and he advises strongly that everybody makes everything very object-oriented. Try to make everything modular and self-contained, and he even frowns on the use of GBLs completely, which I'm not going to disagree with him there, and maybe for his type of code that works. But I think for people in the United States who are used to other PLC platforms, they're going to want to see a collection of tags, and I'll kind of show you where those are here, associated with the module that they're programming. And they don't want to have to dig real deep into a lot of these methods and procedures. Inheritance, all this stuff's very important, and that's what he talks about on his YouTube. But I'm not going to concentrate as much on that, and part of the reason is, like I said, I've got 30 years in Allen Bradley and Omron and Siemens, things like that, and to try to switch to a true object-oriented, structured text-based code is going to be very difficult for me. So actions, transitions, interfaces, you'll see a little bit in that in the software. Watches, same thing that they are in other PLC platforms. They're just little tables where you can look at variables. VISUs, this is very unique to Code Assist and Beckhoff. And what VISUs are, I'm going to show you one of these here. A VISU, and I have one up here, is a little screen. And so this is kind of like running an HMI. And right now I'm not attached, so I'm going to go ahead and connect. There's login, right? It logs in automatically. And now this is running. And the cool thing about this is all I have to do is go down here. And of course, now here's another thing as far as programming and being online and offline. If I go down here and I'm programming, I cannot add a visualization, right? Because I'm running one. So this is the way that runtime works, right? If I go offline, this, now, if I wanted to add something, right? A POU, a DUT, a visualization, anything, I can do that because I'm not logged in. I'm basically programming. Now, so how do you edit online? Well, you don't edit here, but if I change something and then I go here and I say log in, it's going to say log in with the changes that you just made. And I'm going to generally say yes, and it's going to seamlessly log in and connect to the processor and download the changes automatically, which is really cool. Now, sometimes if I did something like a serious hardware change, I might have to do something like this, which is activate the configuration. That means I change something serious. When I do that, I'm doing the same thing as a download in the major PLC platforms. So I am going offline. I'm stopping the machine, disconnecting, basically, not running, downloading everything, making the change, and then going back online. So this is a little bit of the online view. And like I said, visualizations here, they work exactly like right, a regular HMI here. So this, for instance, I think I connected up to this 2 days ago. I've been collecting data. I can do things like turn this potentiometer and use the numbers for various different things. I've got some numerical conversions. I do a percent conversion, things like that. And I'm collecting runtime data, how long I've been in auto mode, manual mode, etc. You can see here I've only been in manual for 3 minutes. So I'll show you a little how that works. Just go into manual. There we go. I'm in manual mode, and then you can see me accumulating time in manual mode. And I'll show you a little bit of the code of how I do that. So a lot of what I'm doing at NTH is I'm having them build a program like mine, right? That's what a lot of this is. We go over troubleshooting and things like that. And then that's the end of the slideshow, but there's much more detail in this class, right? So lots and lots of hardware stuff. And I see maps on here, for instance. This is downloadable from the Automation Academy, and you can go through this course yourself. So this explains, for instance, more detail about the where the license is dependent on the level of performance, right? High performance. I think the stuff I've got down here is like this ARM Cortex. This platform that I'm running right now is this P30 or P40 runtime. I think all of the trainers that we have are running on those right down here in the lower performance. If you want to do things like motion control, you're going to have to get into these much higher performance PLCs. And you can see here they kind of look different. And then you could run lots of EtherCAT servo systems or whatever. So there's a lot more detail in the document in the Automation Academy than there is on that slideshow. You know, I pop things up and then people have to go through more detail. This talks about the licensing and the dongles and downloading the license. You can get it pre-activated. You can put it on your local laptop, or you can put that license permanently onto the controller itself. There's lots and lots in here. And then of course, there's a little exercise, and I try to make the exercises fairly simple. But we are navigating this. We're transitioning to putting a lot of this on a learning management system, which as I create videos for Beckhoff, I'll have the same thing in the Automation Academy. There'll be little tests in there, and there'll probably be more multiple choice rather than fill in the blank. What is the pricing of software based on? I'll have to give several choices there and things like that. This all tells how to install it, mentions the same thing about there's the shell, right? TC shell, TwinCAT shell, or the full-blown Visual Studio. So I've got Visual Studio 2017 installed on my laptop, and I can run it within that, right? And I think that shows maybe down here. So here is my configuration mode, and that's this little picture. Hopefully everybody can see that down to the right. This is also where you do your communication. So these are the routes, and you can see here I've got 2 of those controllers that I showed you pictures of assigned here, and one of them shows as connected and secure. So for instance, if I go to the older firmware, I'll see this show up with just a checkbox. It doesn't show as secure. And these are the addresses. And I go into a lot more detail about the addresses in the class. These are a little bit odd looking addresses, 169.254, but that's actually a kind of a standard IP address for an unassigned DHCP address. And that's how Beckhoff stuff comes in. But they actually communicate via this AMS net ID here. So you can see there's a few other fields in here besides just the address itself. But I am connected to the controller using this. So, and you can always close that down when you're done. It's kind of like RS Links in Allen Bradley. I suppose that's a way to describe it. So go into a lot more detail there. Another exercise. This exercise just says start a project, right? Save it as project one hardware. And I've actually changed that. The reason I did that is because if you had hardware assigned to your project, I didn't know how to run it as simulation until a couple classes ago. I found out that you could just right click on the IO and disable the IO, and it will run as a simulation. So I don't have to be, I can have the runtime on my laptop with no IO assigned to it, and it will run. You just disable the IO and it will run. Lots on communications in here. Again, you could go through this document if you're a member and download this, take a look at it. Lots of, tips in here. Commissioning a new IPC controller. Both ports are configured for standard TCP/IP. One thing to remember when dealing with Beckhoff, and I have to keep reminding myself of this, this is a computer. It is not a PLC. So all of the things that you need to do associated with hardware are just like any other computer. You have to get into the operating system of the computer to configure things. So for instance, I had to go in here and make one of my Ethernet ports a TwinCAT port. It did not come that way from the factory. And I was like, well, where in my TwinCAT software can I set that port? And the answer is nowhere. You have to go into the operating system of the PC. It is a PC, and you go into it just like you would any other PC. It has your Windows registry, and it has your port configurations and everything. So just like going here, right down here, and attaching to these things, right, network and internet settings, you do the same thing on the PLC. It is a PC above all else. So all the hardware associated with it are PC things. So I had to change that to TwinCAT. Once that was running, I have a dedicated port that runs only TwinCAT and connects to my IO. That's important. TwinCAT IO is much faster, right, than EtherCAT IO. This is the EtherCAT port right here. So you can see this is a regular gigabit. I keep saying TwinCAT. It's EtherCAT is the communication protocol. So much faster than Ethernet IP and things like that, but you do have to assign that port to that. This is the configuration screen for the, let's see, which one is this? Device Manager, which is how you can log in to the unit itself and get at some of the hardware configurations particular to Beckhoff. So things like the Ethernet port things, they give you connections to that. You can remote desktop into the unit and get at the operating system, this screen that way. Just use remote desktop and log into the PC itself. And then I have the students do the same thing. If you have a Windows CE computer rather than a Windows 10 computer, instead of using remote desktop, you use CER host. And that's a different software package. All those are free. You can get remote desktop and CER host from, just Google it and download it from hopefully a safe site. And I have them go through exercise 3. Project Quick Start, same thing. This is the address I was telling you about. If you really want to get into Beckhoff, go ahead and take these courses. And these are the ones that I had taken. I think I've taken maybe a couple more also. And then, of course, the Beckhoff information system. Very important that you use that. Then I go through some of the IO. Those are all the platforms that I showed before, the 3 trainers. Scanning IO. This is how you scan all the IO. This is where you would write down what all the devices are, place it in configuration mode, scan the controller for devices, list them below. configuration mode. I'm going to show you that real quick. That is, right, if I go in here, this is configuration mode. Actually, this is configuration mode. Restart TwinCAT in configuration mode. And then you would be able to go down here and scan the IO. And it would add the IO to one of these trees down here. This one, all right? So all of my devices would show up here. I'm not going to do that today, but possibly the next Beckhoff webinar, if anybody enjoys this one and wants me to do another one and go into a little more detail, by that time I will have scanned IO into this laptop. But like I said, this came off of another laptop that I was running simulation entirely. Now I'm running real IO, and if I wanted to, I could take this controller, and rather than using a fake e-stop like I've got here, I could go look at my real e-stop, right, hit that. So that's a little bit of a look at that. Again, you go offline, and you say configuration mode, restart in configuration mode. If I don't want to do that, I can cancel. But that's what it would take to scan the IO, is go into configuration mode. So I'm going to cancel, go back online, and we're right back to running stuff. You can see here I got 13 minutes on manual mode. That's a little of how that works. Okay, more of a look at this. I'm going to put that document I was just showing you over here and just start kind of paraphrasing some stuff. So this is how I started this particular program. I created the same logic that you'll see on a lot of my other webinars for Allen Bradley or whatever, and I did it in ladder logic. Now, a lot of people, you know, you talk to people from Europe and they're like, well, why do you use ladder logic? Well, in the United States, that's what we use. You know, Allen Bradley is mostly ladder logic. A lot of maintenance guys are familiar with ladder logic, so I'm comfortable with it. That's kind of where I usually start. And this is a good look at how TwinCAT software looks in ladder logic. It is not particularly hard to deal with. If I wanted to program things, I would go back here, and you can see here I can insert a contact, I can insert a network. There is a toolbox over here to the right, and there's most of your major tools, right? You know, count up, count down, on delay timer, off delay timer, set, reset, reset, set, one shots, all these kind of things are over here. And I basically would click on the rung and then add something, and then make that change, assign it an IO point, and then I can right click on the IO point like this, and I can say, you know, declare this, go to definition, whatever, and then I have to decide where am I going to put that tag. Some tags you would create like this, and they are local. So these tags are only in this system routine. So the first thing I usually do if I'm doing a class or building my own little project is build a system routine. This is the thing that does all the auto manual functions, right, that you saw on that other screen. I create things like an always off and an always on bit. These are pretty good standard ways to do that. In Allen Bradley, for instance, you don't even have to have a contact here. I can just put a straight line with a coil. So I'm used to doing that in my system routine. So that's all I did here was duplicate the functionality of right, the system routines that I do in other things. The difference here is some of my variables here are local, and the way I decide if something's going to be local only to this routine or if it's going to be in a GVL, if I think that I need those tags in other places. So for instance, my system tags. There's a list of my system tags. These are global variables, and other routines can pick these up. So my auto mode and my manual mode are in global routines, right? All these things are used by other routines. So for instance, auto and manual mode, if I wanted to run a routine that has something like, let's see, I have a sequence, little light sequence here. And I think this is sequence 1, auto command 1. Actually, this is probably a bad example because we haven't even really talked about what SFC does. But I believe I have this only running if you were in auto mode. And I think let's pick up a transition. Let's see. Yeah, there we go. See how it says sys auto cycle, right? Transition 1 says auto equals, I pass it a variable, and that variable is system auto cycle. So I'm passing that in here, and then pretty much all the other stuff is either local, or in this case, I made a fake sensor that is a push button. So take a look at that. That is, why am I not switching? Oh, not logged in. Now I'm logged in. Now my sequence control works. So that's this push button, right? Put it in auto mode. Show you a little of the functionality of this. I'm in manual. I was doing that just for time collection. We'll go into auto. Okay, do a cycle start. And I think this next time, beep, beep, beep. There we go. We're in auto cycle. Now, if I go to my sequence control, you can see that this thing is running based on time. If I put it in push button mode, then it runs based on push buttons. So this is a simple illustration of how to use SFC that I have the class do, because they don't know what SFC is, because most of what they program is Allen Bradley. So I give them a little bit of a taste of every language and have them run this code either based on time, where it'll sequence through these things, or based on, let's see, okay, I see Matt here. Let's see anybody else. I saw your thing flicker there, Matt, and I'm not sure if you have chat. I didn't know if you were trying to ask a question, but I got a hacker last week and or 2 weeks ago, and somebody put a bunch of really nasty stuff. So I was just making sure that people weren't throwing stuff in there, but I think you're the only other person here right now. So anyway, that's a look at this SFC. You can see here I'm able to switch screens and things like that. Some of the visualization tools. Again, if I log out, now I'm in program mode for this visualization. And if I click on an object, I get all these properties over here, right? And so, for instance, this, I believe somewhere in here, one of these properties, text variables, nope, no text variables. I'll show you something that's a little simpler. This. There we go. So this is where, for instance, I have assigned a variable to this, SimIO potentiometer 1, and that has the link into the PLC, and then you're able to change these numbers based on that. So like a regular HMI, except that rather than double clicking on this and getting a dialog box like you would get in Allen Bradley or Siemens or Omron or whatever, here you're using these properties over here on the right, and there are lots and lots of properties. You can figure out how you want it to look. You can change your background colors. You can scale things. You can do whatever, and you can assign tags to a lot of these. So for instance, if I wanted to move an object on this screen dynamically, I could make something that's running right here in my code, and then assign this position, for instance, X position, to a variable, and you would see this potentiometer actually move right and left. That's kind of that's how you do some of the animation that you would do in Allen Bradley, for instance. So again, this is the programming side of it, And there are some things here that are a little harder to probably understand than your typical PLC or HMI programming. For instance, this one here, this 5 is the number of characters that would show up here. It is in integer format. This one here is in floating point format, 3 and then 1 space, and then I forget what the percent is. I'd have to look that up again, but I believe that just means it's a variable, right? It's assigned to, let's click on one of them. Right, it is a text variable. So this is assigned to data tag, data autocycle RT, and this is a UDT. Actually, like I said, they call them DUTs here, and then seconds. So to link to this, right, this is just like a UDT in Allen Bradley. Where are my DUTs? There they are. So for instance, here I've made a runtime structure. There it is. Right. So when I said something was minutes, any tag that is assigned to this data type will have the set point, the seconds, the minutes, the hours, and a service bit. What I use the service bit is, like, for instance, if you were doing runtime on a motor, the motor hits 10,000 hours and the service bit comes on. So that allows you to get a set point for a function block. This UDT then is assigned for my data collection into, let's see here, data, I believe here. So this is where I actually assign, right, manual runtime. There's where I assign variables. And I did all this in structured text. I could have done this as a block, right, and had it in here like ladder or function block or whatever. Here's an example of what function block would look like. So I could have a block here with all these variables sticking into the left side, right? That would be the way that would look. And this is a little more familiar to people who are doing like ladder logic. So, you know, my system routine, I have various blocks in here, and these are just function blocks, right? So here is a light blinking pulse. I give an on time and an off time. And then I actually have a function block that runs this pulse timer. Very simple logic. Let's see if I can find it. I put all my function blocks in a separate folder here. So that's another thing you can do in Beckhoff and TwinCAT is I can make new folders within things. So this function blocks folder did not exist. I simply created it. All right, I went in here and I said add a folder, and then I named it function blocks so that I can find all my function blocks. That runtime function block, there it is. There's what structured text version would look like if runtime seconds .q is up, then add a minute, right, and reset runtime seconds. So this is a cascading timer like I have in my the advanced PLC book. I give an example of cascading timers and counters. If minutes greater than or equal to 60, then hours equals hours plus 1. That's just an accumulator. Reset minutes back to 0, and it's an if statement. So this would have been done in Allen Bradley, of course, in ladder logic, probably. Most people would choose to do that because ladder logic's free in Allen Bradley. That's another reason that people don't use structured text, because they don't all have structured text installed on their Allen Bradley processors. You have to pay extra for that. So that's a little bit of the logic. That's what these runtime function blocks look like. And then I also say if the hours are greater than the set point, then the service bit is true. So for instance, go replace the bearing on your motor because it has 10,000 hours on it or whatever. So this is a pretty standard function block. And again, this is available on my blog if you want to see cascading timers, or in the Automation Academy, or in my book. So to see what that would look like in ladder logic. see what else we've got here. These are functions. So here's a scaling function. The difference here is I am not retaining any memory here. So I have a percentage that I put in there. I put an engineering min and engineering max, and it allows me to scale things. And then I can pass out my scaled value. That's how I did the percentage on that potentiometer, which was here. We'll go back into run mode. And where'd my HMI go? There we go. So this percentage, that's how that's done. That's simply scaling the raw value. I made the raw go from 0 to, should have been about 32,000. There you go, 100%. Because if I would have used 32,767, which some people are familiar with as being the range of a 16-bit number, these numbers get screwed up. So I'm not really sure how people normally would do these, right? But this was close enough, 32,000 to 32,767, and then I was able to evenly divide these numbers and make this look nice. So that's kind of the reason I did that. So that's kind of a look at the mathematical functions. And so the goal of when I'm doing classes like this is to give people an example. So notice this shows question marks. So this is one of those things, because I scale more than one thing, you have to say, well, which value do I want to look at the scale for? If I'm scaling 10 things and I open up this block, which one am I looking at, right? This runtime. This is an example of that. Online mode, which one do I want to look at? Well, I think we're in, are we in manual? No, I think we're in auto cycle. So I'll look at this one. I'll say I want to look at that one, and then I get the numbers for that specific block, right? Because I'm doing 5 different blocks here. So if I want to look at that in real time, I say, which one do I want to monitor? And then it looks like, actually it does say auto cycle RT. So I know which one I'm monitoring just from looking at that. So that's a little bit of a look here at this. This program that I've created here has been through about 3 different classes. I was looking for this before. This is function block. So this is an example of how a function block diagram looks. And I need to remember that because I created a separate test FBD and I wanted to put some code in there. But this code gets the local time. So this is a pretty elaborate thing. And I'm going to actually, full disclosure here, say I did not really create this. I looked online for how do other people do this and then kind of modified it myself. So I'm getting local date and time in several different ways here. Right? But there's a lot of help files, right? System time to date and time. So this is a data conversion. Take the preset value and convert it, pass it into this variable, date and time, right? And this is how I get my local date and time here. That's one of the things I have people do in the class, is go ahead and create a field so they can pick up local date and time and log events. Right? So when did I turn this potentiometer? That sort of thing. There's another thing I'm monitoring. Now, normally I like this separate, right? It kind of looks like a regular HMI that way. I can flip between things. This one I think I've showed before. Typically what I do here is I have people create all the system things that you would normally want. And so for instance, there we go. I just hit the E-stop. What did that do? It took me out of auto cycle. It put me into a fault. It told me the fault number, which comes from one of these routines down here, right? Faults. There's a little bit of that logic, right? So I'm monitoring things. It says, okay, you have an E-stop 1 fault. If so, your system fault message is 1. Now I'm going to reset the E-stop. Okay, I fixed that. Now I have fault number 3. That is the MCR is not active. Here, I press the power button, all the faults have been satisfied, but I still have to reset the fault. If I try to reset it, right, it won't permanently reset if I have this. So fault 1, actually, this is a little bit of an error. If I hold it down, it does hold it reset. I wouldn't normally want to do that. So reset it, power up. This is all simulated stuff. There we go, fault's gone. I run all this down here in this simulation routine. If not e-stop button and not power button, then MCR is true. So this is faking a master control relay. Else, if the e-stop is false, then the MCR is true, is false, right? So this would turn off the MCR until you press the power button. So again, structured text, a little hard to monitor, but I want people to get into the habit of using structured text because that seems to be the main language for Beckhoff, right? Beckhoff and TwinCAT. Most people like to use structured text, especially overseas. Like I said, I'm not, I'm partial to whatever language is best for the customer, best for the maintenance guy who has to maintain the equipment, and what is easiest to read, right? Easiest to debug. So I'm not, you know, people are having a lot of discussions right now, I think, on LinkedIn about what language is best. All languages are fine. They all accomplish the job, but which one's more readable? If somebody had to debug something, some of these are tough. I think this one, students in the class do not like this. I will tell you that because this is kind of hard to program, right? Sequential function charts. So a lot of people don't so much like this, but this is very modular programming. SFC has its pluses there. So that's why I did this. When I do this class, again, I give them one example in every language. So go all the way down here to the end. This is the information that I would typically give them. There's the IO, assign everything, make your local variables, which I realize Jacob doesn't like so much of the GBLs, but this is how I do it. It's more similar to Allen Bradley or Siemens that way. Then I go into ladder logic. I have them create this system routine. So I just let them copy what I've already got, show them how the watch tables work, right? And then start getting into structured text. Do if-then statements, case statements, kind of show your standard structured text is, you know, examples like Python and, you know, Fortran and C and a lot of those different languages that have declared variables and if-then statements. That is structured text. So I have them do a couple things in structured text. Then I have them create the simple visualization that I showed here, right? And I've elaborated on a little bit, like I said, the simulation with the e-stop, add a reset button for the fault, right? So mode control, talk about libraries and bringing in different library things. I'll show where that is here. That is in these references. So as you do, let's see, where is references here? There we go. As you do things like create these visualizations, it's going to automatically go out and grab things from these libraries and bring them in. One of the problems I had when I was running this other version, Build 4020, is the references in the libraries came from version 4024 and they weren't right for 4020. So I had to get with tech support and try to figure out which libraries were correct for that older remote manager. And we never really did get it resolved. We had 500 errors, compilation errors, and it was a matter of going to the, let me see here if I can find it. I may have to be offline to find it. See, and I forget where it is right now, but oh, there we go. Library repository. So there are a lot of different versions of libraries. And if you don't have the right library assigned here in these, right, in these library files, you're going to have all kinds of problems. If I select this, I'm going to see, right, the properties for this. It is going to show me something like this, right? This 3.5.13.0 default. And if you don't have that version right, you won't be able to compile your program. And that causes all kinds of problems there. So our hour is pretty much up. This was, like I said, a look, and this will, of course, be on YouTube. I think I've been into most of the routines that I've got down here, which again, they call them POUs, right? Program Organizational Units. I've got a little bit of an example of everything in here. I've got some function block, some SFC, probably lots of structured text, right? I did do some function block here because the examples I found were in function block, which was good. Very simple, right? This block does nothing but sequence test. Light time equals not light time this, and it just helps run some of these units. So another nice thing, you do get used to this. You're going to very quickly be able to figure out, am I running, am I monitoring everything, or am I offline basically in program mode? If I'm in program mode, then I make a change and I hit this online button, and it will say, do you want to engage? Do you want to engage this? I got a message from Matt, enjoy the presentation, have a poor internet service, it's dropped the connection. I get it. That's happened to me before too, and if I were presenting and that came on, that would be a problem, right? But so far, it's never crashed in the middle of doing a presentation. But anyway, any questions about any of this? Right, we are down toward the end of the presentation here, and again, this is a 5-day course. What I do in that course is I walk them through all these different languages, all these different application things, have them build their own program. And then the last day, I cut people loose on whatever their interest is. So I've had people, for instance, one guy did a pick and place where he animated the movement of the objects on the screen. That was fun. I've challenged a few people to do things like grab data from something like this data routine and log this data to a SQL database, right? Which would be a good use because you could put the SQL on the PLC if you wanted to. You could put it in the controller. You could put it in your runtime on your laptop and do data acquisition that way. I've had people write sequences in the other languages. That's, of course, let's get this back into auto cycle start. Beep, beep, beep. There we go. We're in cycle start, and now we're running here. There we go. Notice this blink's kind of funny, and the reason is in these sequences I have, right, some of these transitions are different than others. These are the transitions. So this is a typical object-oriented programming. You can make methods, transitions, actions that are attached to these, and then put the code inside of just the transition. And what you see here is these transitions are a little different. Time pulse. I think I used different methods here in the sequence block. This is a D, this is a D, and I think the Ds are different. That's the difference here. 500 milliseconds, 500, 500, and immediate. So that's why it kind of hesitates on some of the blinks, because the transitions are different, right? Ns versus Ds. So this, like I said, this is the part of the class that most of the students don't like this. They say, I would not choose sequential function charts for any of my programming. But, you know, SFC is a legitimate language, just like structured text, just like function block, just like ladder. So there's nothing wrong with using that. Anyway, that is a look at it. Here's outputs in ladder, and here's outputs in text. You know, up to you how you want to do it. Right. This is the simulated I/O. This is the HMI point. That's why this looks like this. It's not the best presentation of ladder, but it accomplishes the purpose. Did some scaling here in ladder. My simulations in structured text because it's simple and small. And that is pretty much how that works. Go ahead and drag this back. All right, I'm gonna go ahead and shut this down. The next webinar, probably June 24th. That's about 2 weeks. I will be going to Miami to work at ABD, which is a beverage plant down there, for another 2 weeks. And I don't really want to do it from Miami, but I might. I think July 1st maybe is a week after this 24th, or maybe that's the something like that, the 1st or July 30th. So I may do that from ABD and just do a live show from ABD and show some of their equipment or whatever. But anyway, this has been Mastering the Machine from the Automation Academy. Feel free to check out these sites. A lot of that Beckhoff document that I showed you is on the site. That's in the library at the Automation Academy. You know, sign up at IO Central. IO Central is free. Of course, this here, you have to be a member to get at a lot of this stuff, but IO Central is free. You can ask questions on there. There is a Beckhoff group. So, you know, join in there and say hi to everybody. In any case, that is it. And thanks a lot for hanging out. And this will be on YouTube. Yes. Hello, this is possible. Take this video presentation, Edgar. Yes, this will be on YouTube. So you'll be able to watch the whole thing there. Just go to YouTube, Automation Consulting or Automatic Eye. I don't really, there's another way to put the link, but it's got a whole bunch of letters and numbers and things in it. If you do a search for Automation Consulting, you'll find it. This Academy, I have course online. No, I do not. Not for Beckhoff. I have online courses for Allen Bradley, Siemens, Omron. Do not have Beckhoff yet. I'm working on the video course for Beckhoff. Unfortunately, video courses take a long, long time to create, and I'm in the process. I just created a PID course. That's what I did, I think, my last presentation on. I do have that. So yes, online, but not in person online. That takes signing up students. I do that for automation training. Automation training has online courses, live online courses with real instructors. So that's probably the easier way to do that. And I teach for them also. So yeah, the Automation Academy, I don't have line stuff. Many issues with TwinSafe. Well, yeah, that's integration. That's a whole different thing. TwinSafe is the safety PLC aspect of this, and that's debug. That's, you're going to need help from the Beckhoff folks. We have very good tech support here in the US in Minneapolis, and so I get help from them. But again, they're not going to come to your site and help you. That's where you know, typical debug and integration skills. I try to help people with integration skills where I can, but that, you know, one-on-one help. You know, everybody works for a paycheck, so that's VIPA and Beckhoff always fight at the interconnection. That's very possible. VIPA is Siemens. It's faster than regular Siemens. It's an alternate software, but choices of what people put into their systems. You know, this is like Allen Bradley and Siemens fight a lot too. And if you try to make them talk to each other, that can be really tough. But in any case, like I said, I'm going to go ahead and end this presentation here. This has been a presentation of the Automation Academy, Mastering the Machine. Check these sites out. Connect with me on LinkedIn or on YouTube. You know, check out the video and give it a like if you get a chance. And thanks a lot for attending.